Welcome back, geometry students. Happy Halloween, and welcome to section 3.5, parallel lines and triangles. Super useful section here, the 3.4. That one was pretty light. This one's like your main course. This is going to be one that you use throughout the rest of your high school career, so make sure you guys are paying attention to this one. Let's get started. This first one, not really a useful thing. I know I said this is a useful section, but this first one's kind of, in my opinion, pretty obvious. How many lines can you draw through point P that are also parallel to line L? And the answer is, do you have a prediction? Do you guys have a prediction yet? Go ahead and say your prediction out loud. Tell your neighbor. Okay, no predictions, whatever. There's only one. There's only one line you can draw through point P that is also parallel to line L. Okay, so there's only one line that satisfies those conditions. Now, that was just that out of the way. Now we're moving on to triangle angle sum theorem. Very useful here. You may even do an exercise here where you cut off the angles. If you draw a triangle on a piece of paper and you line it all up, and you'll see that all three of these angles need to add up to 180 degrees. Maybe some of you have heard this before, but three angles in a triangle always need to add up to 180 degrees. If it doesn't, then there's something wrong. It is not a triangle. So let's go ahead and expand on this idea using the triangle exterior angle theorem. Now, this is talking about exterior angles. So the exterior angle here is this one, angle 1. So this is an exterior angle. Why is it an exterior angle? Because we have a triangle here, and these would be on the interior. Okay, so these are all on the interior, whereas this guy is on the exterior. So it's kind of self-explanatory, but just in case, I like spelling it out for you guys so you know that that's an exterior angle on the outside of a triangle, and these three on the inside are interior angles. Now, this angle right here, I don't want you guys to get confused. This angle, let's make it purple. This one is supplementary to 1. So we can call this, I don't know, angle M. These two are supplementary, okay? So when you're talking about exterior angle sum theorem, you're not referring to this angle that's already supplementary to it. What you're talking about is angles 2 and 3. Now, these are called remote interior angles. Okay, these are remote interior angles. Why are they called remote? It's not like remote control. It's called remote because it's like a remote island. It's far away from the exterior angle. So you see here, here's our exterior angle. Okay, here's our exterior angle. These are the farthest they can be on the inside from that angle. Okay, whereas this angle M that we called earlier is close to it. It's supplementary to it. So when we're talking about remote interior angles, we're talking about the two angles that don't touch the exterior angle. Okay, so what's the amazing formula here? The amazing formula is, let me change this color. Angle 1 is equal to the sum of angle 2 plus angle 3. Okay, those two must be the sum of 2 and 3 have to equal 1. Okay, and we're going to see how that's put into practice. Technically, you don't even need to use this. You could just use supplementary angles and then go from supplementary angles and add up to 180. This is kind of just like a shortcut. So try to implement this if you can. It's not required per se. You'll end up using it without even knowing that you're using it, but it is a shortcut that speeds up problems for you big time. And I guarantee you'll see something like this on a standardized test or an ACT. Okay. So let's go ahead and put this into practice with example 1. This is our one and only example. Kind of a sad-looking pumpkin here. Maybe we should make a face on him real quick just so he doesn't look so sad and lonely. Get some triangle eyes, maybe a triangle little nose, and then we'll get him like a little mouth. Okay, just to make him not so sad looking. Boy, it looks like he's got some blemishes. He's got some skin problems. He's just not having a good October. Okay, so now he's looking a little bit better. Okay, so let's go ahead and move on after that little drawing lesson. So bunch of different opportunities we can start with here. With this, most likely I would start with Y, just because it's supplementary to 60. So there's a bunch of different ways to do this. I'm going to try to show you all of them if possible. But Y, we know plus 60 is going to equal 180 because they're supplementary, okay? They form a linear pair here, okay? So they add up to 180. So clearly we know that y, which is red, I should stick with red, y equals 120. Okay, so we can find y equals 120 that way. I'm not going to write it in because I'm going to show you another way to do it. And z we could easily find because we know that z is also supplementary, linear pair with 70. So we know that z plus 70 equals 180. So then we know that z equals 110. Okay, so we have that one. And then we'd have x and a. Now, one of the things, we could find x by saying, okay, well, we have 3 angles of a triangle here. Okay, if you guys can see the triangle, maybe I'll draw it so you guys can see. So here's the triangle. And we have 3 angles. It's 70, 60, and x. So we know those 3 angles need to add up to 180 because that was the triangle angle sum theorem. So we can easily solve for those angles. We get 130 plus x equals 180. And then we get x equals 50. Okay. Then from there, we could easily find a by using the supplementary. It's supplementary to x, so we know that 50 or x plus angle a equals 180. So we subtract 50, and we get a equals, what's that, 130? Yeah, okay, so we get 130. So we have all those angles. Now, I want to show you how you can do the same thing using the, the exterior angle theorem. Okay, so let's start with angle A because we're given the 2 remote interior angles to A. Okay, the other interior angle here is supplementary, so the remote ones are not touching A. So we know that this is true. We know that 70 plus 60 is going to equal A. No need to subtract from 180 here. What do we get? We get 130 equals A. So in a sense, this is a faster way to do this problem. Okay, so now that we have that one, we're good. We have 130 done. Now, from here, you would figure out that x is supplementary, so it'd find that x is 50. And now we have all the interior angles, so now we're ready to roll with, for example, z. So we know that z, using the exterior angle theorem, is going to be equal to its remote angles. Now, the remote angles change because now the exterior angle has changed. So what are the remote interior angles to z? Well, now they're 60 and 50. So we can say z equals 60 plus 50. We get z equals 110. That's the same thing we got earlier using the supplementary angles property. Okay. Now, the last one we're going to do is y. So y, again, the exterior angle change, so now our remote interior angles change. Now we have the remote interior angles of 50 and 70. So we have to add those two to find y. So we have y equals 70 plus 50. We get 120. And that's what we got the first time around. So you can see there's 2 different ways to do this problem. In my opinion, the exterior angle theorem is faster if you can recognize it, but you will not be wrong using supplementary angles and, of course, the triangle sum theorem. Angle sum theorem. So I hope you enjoyed this video. Thank you so much for watching, and I'll see you next time on West